All right, let's talk about the software that quite literally designs the world around us. I mean, everything from the roads you drive on to the ground your house is built on. We're diving into the world of Civil 3D. Seriously, have you ever been driving on a highway that's cut into the side of a mountain and just thought, how in the world did they figure this out? How do engineers take a huge, messy piece of land and perfectly plan every single curve and every single hill? It's a massive challenge.
Well, it turns out the key is to treat it like a giant digital puzzle. The secret is to turn the real, physical world into an intelligent, dynamic model that you can work with on a computer. And that is where the magic really starts.
So, think about the fundamental problem for a civil engineer. You're sitting in an office, maybe miles away, and you have to design something that's going to be built on land you can't even see. You can't just eyeball it. You need a perfect digital replica of that land to get started.
So, the very first step is to digitize the real world. This is where surveyors come in. They go out into the field with all this high-tech gear, like total stations and GPS, and they collect thousands and thousands of incredibly precise data points that map out the entire topography.
Now, these aren't just simple dots on a map. No way. They're called COGO points, which stands for coordinate geometry. Each one is basically a tiny package of information. It knows its exact location, X, Y, and Z for elevation, but it also has a description that tells the software what it is, like centerline, or edge of pavement, or even oak tree. They're smart dots.
Okay, so now you've got this massive digital cloud of thousands of intelligent points. What do you do with them? This is where Civil 3D does something truly brilliant. It essentially plays a giant game of connect the dots, triangulating between all of them to create one single continuous 3D object.
And that object is called a surface. It really is like a digital skin that's been stretched over all those data points. It becomes a perfect digital twin of the ground, capturing every contour, every slope, every single hill and valley of the actual terrain. And just like that, we now have our digital land.
With our digital ground ready to go, we can finally start designing. And the first thing you have to do is define the road's basic path. Where is it actually going to go?
This really comes down to two key views. First, there's the alignment. This is the bird's eye view, the path of the road, as it winds through the landscape. Think of it as the center line. Then you have the profile. This is that same path, but seen from the side, as if you slice the earth right open. The profile shows the vertical journey, how the road goes up the hills and down through the valleys. So now we've got the path and we've got the elevation. But that's still just a line, right? How does it become a full-blown 3D road? Well, that's the final piece of the puzzle. To make it happen, we need something called an assembly. And honestly, the best way to think of this is like a cookie cutter. The assembly is the cross-section, the typical shape of your road. It defines exactly how wide the lanes are, where the curbs and sidewalks go, and what the slope is for drainage. It's the road's repeatable shape. So creating the final 3D model, which is called a corridor, is actually like a simple recipe with just three main ingredients. You need the path, that's your alignment. You need the elevation, that's the profile. And you need the shape, and that's the assembly. What Civil 3D does is it takes that assembly, our cookie cutter shape, and it stamps it all along the path of the alignment, while perfectly following all the ups and downs defined by the profile. And just like that, boom, you have an intelligent, fully formed 3D model of your entire road. But this, right here, is where Civil 3D goes from being just a great design tool to an absolute game changer. That corridor we just built, it isn't a static drawing. It's a living model. And here's the real magic. If an engineer decides a slope on the road's profile is a little too steep, they can just grab it and move it. They don't have to redraw anything else. The software understands the relationship between all the pieces. You make one little change, and Civil 3D automatically figures out everything else for you. The moment that one change is made, the entire 3D corridor rebuilds itself. The cross-sections all update. And maybe most critically, all of the earthwork calculations, figuring out exactly how much dirt you need to cut from a hill or fill in a valley, which is a massive cost on any project, all of it is recalculated instantly. So the payoff is just huge. Dynamic modeling keeps the design accurate and saves an incredible amount of time. It lets whole teams collaborate on the most current data through the cloud. You get precision analysis with detailed reports generated automatically. And it automates all those boring, repetitive tasks like creating hundreds of cross-section drawings. And from this one single intelligent model, engineers can generate absolutely everything they need for the real world. We're talking the final construction plans for the crew on the ground, all the cross-section sheets,
detailed reports on material volumes, and even beautiful 3D visualizations to show stakeholders exactly what the final project is going to look like.
It really makes you think, doesn't it? This level of dynamic, data-driven design isn't just about building a road a little more efficiently. It's about building smarter, more responsive, and more sustainable infrastructure. In a way, it's the blueprint for the world of tomorrow.